What if the first definitive proof of alien technology wasn't a grand arrival but a single ambiguous frame of data on a NASA live feed, visible for just a fraction of a second before the screen went black? This is the story of a hypothetical event, a thought experiment grounded in real science. On June 18th, a NASA feed tracking a fictional interstellar visitor named 3I Atlas suddenly cuts out. But not before revealing something that looks eerily artificial. Was it a simple glitch or our first glimpse of something engineered? Let's explore this together. The initial discovery. So, how does a story like this even begin? It starts with the silent, relentless work of a real program, the Asteroid Terrestrial Impact Last Alert System, or ATLAS. Funded by NASA and operated by the University of Hawaii, this network of robotic telescopes with key figures like principal investigator Larry Deneau at the helm, scans the entire visible sky every 24 hours. Its primary mission is planetary defense, but its wide, fast survey is perfect for catching interstellar interlopers. In our scenario, on July 1, 2025, ATLAS flags an object on a hyperbolic trajectory. This isn't just another rock orbiting our sun. Its path proves it's a visitor from another star system, moving too fast to be captured by our sun's gravity. After its trajectory is confirmed by the Minor Planet Center, it's designated 3Y Atlas. This would immediately trigger a global astronomical response. Scientists like Karen Meach, who led the characterization team for Oumuamua, would spearhead campaigns to observe the object with every major telescope available. This isn't just about getting a picture. It's a frantic race against time to gather data on a messenger from a distant, unknown solar system before it disappears back into the void forever. The anomalous frame. Here's the moment a routine observation becomes a profound mystery. A public live feed is tracking 3I Atlas. At precisely 03:17:12 UTC, the feed freezes on a final frame before cutting to black. The image is mostly standard deep space fare, a dim, fuzzy nucleus surrounded by a cloud of gas and dust. But in the lower left quadrant, something is different. There is a razor-sharp glint of reflected sunlight forming a perfectly straight line. This is the kind of anomaly that would make a SETI pioneer like Jill Tarter take notice. Natural objects in space, comets, asteroids, dust clouds, are chaotic and irregular. Light scatters off them in diffuse, uneven patterns, but this glint is geometric. It behaves as if it's reflecting off a polished, flat surface. Independent astronomers running their own analysis software would see their edge detection algorithms flag the segment immediately. It's too consistent, too crisp. In the long search for extraterrestrial intelligence, this is exactly the type of technosignature researchers look for. An artifact that appears manufactured, standing out starkly against the random backdrop of nature. The question is no longer just what is this comet made of, but was a part of it made at all? Data verification. An image this provocative is worthless if it can't be authenticated. This is where the modern, decentralized nature of science communication becomes critical. In the minutes after the blackout, a global network of independent archivists and citizen scientists would swing into action. They run automated scripts that continuously record public NASA feeds. Packet captures of the 3I Atlas feed from servers in Germany, Australia, and the United States would be uploaded to multiple repositories. Each file, timestamped 03:17:12 UTC, is protected by a unique cryptographic hash, a long string of characters serving as a digital fingerprint. This concept, with roots in the work of cryptographers like David Chaum, ensures data integrity. When compared, every single archived file matches bit for bit. The German hash is identical to the Australian hash, which is identical to the original broadcast. This provides undeniable proof that the frame was not altered, manipulated, or a hoax created after the fact. The chain of custody is forensically sound. The evidence is clean. The anomaly, whatever its cause, was genuinely present in the data stream from the spacecraft. This eliminates any possibility of a simple prank and forces the scientific community to confront the data as it is. Technical explanations. Before we entertain alien explanations, we have to exhaust all the mundane ones. So, why did the feed drop? The most probable official reason would be a routine network handover. NASA's deep space communications are a marvel of engineering, managed by experts like those at the Jet Propulsion Laboratory, but they aren't flawless. Signals travel from a spacecraft to a relay satellite in the Tracking and Data Relay Satellite System, or TDRS, then down to one of the 3 deep space network complexes on Earth. As the Earth rotates and satellites move, the signal must be handed off from one station or satellite to another. An engineer like Mark Raymond, known for his work on missions like Dawn, would explain that these handovers can occasionally cause a brief loss of signal. These handover blanks are common, logged, and typically last for a few seconds. They show up as a gap in the data logs with a specific reason code, so a blackout is not in itself a conspiracy. The entire system is built with these brief interruptions in mind. The deeply unsettling part of this scenario isn't the blackout itself, but its timing. A routine technical glitch occurring at the exact nanosecond a potentially paradigm-shifting anomaly appears on screen is a coincidence of astronomical proportions. Digital forensics. Let's put the frame itself under the microscope. Digital forensics is an unemotional discipline, and it offers two powerful non-exotic explanations for the straight edge. The first is video compression. To transmit massive amounts of data across millions of miles, images are compressed using algorithms like JPEG or MPEG. These codecs, whose development owes thanks to computer scientists like Ken Perlin for their work on procedural textures and noise, divide an image into an 8x8 pixel grid. When a faint linear feature happens to align with the grid's boundaries, the algorithm can snap it into a perfectly straight line, exaggerating its geometric appearance. It's an artifact of the math, not a feature of the object. The second culprit is a cosmic ray. Space is saturated with high-energy particles that constantly bombard camera sensors. A particle can streak across a sensor's pixels, leaving a bright, and often perfectly straight trail that lasts for only a single frame. This is a well-documented phenomenon. The most likely forensic conclusion would be a double hit. A cosmic ray created a faint streak that was then amplified and sharpened by the compression codec. It's an elegant, logical explanation that fits the evidence without rewriting any textbooks. But it can't entirely rule out that it was a real object that was simply processed by the same algorithms. 3i Atlas background. To grasp the full weight of this anomaly, we need to remember the real interstellar objects that preceded our fictional one. First came one Oumuamua in 2017. It was a complete enigma. Small, dark, and highly elongated, it showed no visible coma or outgassing, yet it accelerated away from the sun as if something were pushing it. This led Harvard astronomer Avi Loeb to famously propose it could be an artifact of extraterrestrial technology, like a solar sail. Then, in 2019 came 2I Borisov. It was a much more familiar sight, looking and behaving like a classic comet with a clear coma and tail, though its chemical composition was unlike anything from our solar system. These two real visitors set the stage perfectly. They proved that interstellar objects are a reality, and that they can be profoundly weird. Oumuamua, in particular, primed the scientific community to be on the lookout for anomalies. It opened the door to seriously considering technological origins. So, when 3I Atlas appears in our scenario with its own bizarre feature, it doesn't happen in a vacuum. It lands directly on the fertile ground of unresolved scientific debate and public fascination that Oumuamua left in its wake, making the stakes infinitely higher. Scientific scrutiny. In science, an extraordinary claim requires extraordinary evidence, a principle famously championed by the great astronomer Carl Sagan. A single, ambiguous frame from one instrument is, honestly, the very definition of not enough evidence. For the so-called artificial edge hypothesis to be taken seriously, it would have to survive a brutal gauntlet of scientific scrutiny. First, the observation must be independently replicated. That means different teams, using different telescopes like the Hubble Space Telescope or the Keck Observatory, would need to observe 3I Atlas and confirm the presence of the same geometric glint. Second, it needs to be a multi-wavelength detection. If the glint appears in visible light, does it also show up in infrared and ultraviolet? Spectral analysis of the glint itself would be crucial here. If the light signature matched a known metallic alloy, rather than silicate rock or water ice, the claim would gain significant credibility. But as it stands in our scenario, the evidence is anecdotal. It sits really on the lowest rung of the evidence ladder. Until multiple independent data streams confirm the same anomaly, the overwhelming majority of scientists would, quite rightly, remain deeply skeptical and favor a natural or instrumental explanation. The burden of proof is, and must be, incredibly high. 3 theories. After all the analysis, the scientific community and the public would be left grappling with three divergent paths. The first is the most conservative natural phenomena. A leading cometary expert, perhaps someone like Paul W. Chodas from NASA's Center for Near-Earth Object Studies, would argue that what we saw was a glint off a freshly exposed face of ice. Comets are dynamic bodies. As they heat up, jets of gas can erupt, putting immense stress on the nucleus and causing it to fracture. A large, flat piece of ice could easily shear off, and if it catches the sunlight at just the right angle, it would produce a sharp, geometric glint before tumbling away. The second path is the technical glitch theory, a perfect storm of a cosmic ray hitting the sensor in a straight line, which is then exaggerated by the video compression algorithm. It's an illusion born from the interplay of physics and software. But the third path, the one championed by thinkers like Avi Loeb, is the most profound. It posits that the object is not natural at all, that the edge is a real manufactured component of a larger object, a probe, a solar sail, or even a piece of interstellar debris from a civilization long gone. It is a long shot, but it remains a possibility that cannot be disproven with the available data. Broader implications. An event like this, even a fictional one, would transcend the world of astronomy and have profound societal implications. As Seth Shostak of the SETI Institute has often noted, the discovery of potential intelligence would change our perspective on everything. The immediate aftermath would be a firestorm of public debate about data transparency and potential cover-ups. Why did the feed cut out? Who made that decision? This would lead to intense pressure on government agencies like NASA to adopt even more radical open data policies, perhaps mandating decentralized real-time public archives for all raw telemetry. Funding priorities in science could shift overnight. Congress might allocate emergency funding to projects dedicated to the search for techno-signatures. The event also becomes a massive test of global media literacy. How does the public distinguish between credible scientific analysis and wild speculation? For a world watching, the line between healthy skepticism and unbridled wonder would blur, forcing a global conversation about our place in the cosmos and how we prepare for a discovery that could change humanity forever. One single frame could permanently alter how we look at the night sky. The search continues. While our story of 3I Atlas is a thought experiment, the real search it describes is entering a golden age. We are on the cusp of a revolution in astronomy with the imminent full operation of facilities like the Vera C. Rubin Observatory in Chile. With leading scientists like its director Zeljko Avezic guiding the project, this observatory will conduct an unprecedented survey of the sky, discovering potentially dozens of new interstellar objects every year. This will transform the field from a data-starved science into a data-rich one. Each new visitor will be a data point, a clue from another solar system. Scientists are now actively developing the AI algorithms and observation strategies needed to characterize these objects quickly and efficiently. They are no longer just looking for comets and asteroids. They are actively hunting for anomalies. They are looking for strange light curves, unusual chemical compositions, and most importantly, objects that move in ways that defy our understanding of physics. The search is on, with more powerful tools and a more open mind than ever before. The next visitor is coming, and this time, we will be ready. The unresolved mystery of the 3I Atlas frame, though fictional, perfectly captures the tension between mundane explanation and profound possibility that drives science forward. It forces us to ask how we would react to a truly ambiguous signal from the cosmos, and highlights the absolute necessity of open data, rigorous skepticism, and relentless curiosity. What do you believe is the most compelling explanation for the anomaly and the blackout? Share your theory in the comments section below. Don't forget to like, subscribe, and hit the bell icon for more deep dives into the greatest mysteries of our universe. Thanks for watching Simply Science. A fiery streak from a distant star, or just a trick of the light? On October 7, 2025, the European Space Agency drops its first image of an interstellar comet, and the world ignites with controversy. While official channels offer blurry photos and technical excuses, NASA and other global agencies go completely silent. Amateur astronomers, however, start releasing sharper images from their own backyards, fueling speculation and outrage. What are we not being told? Let's explore this together. The blurry dot. It was supposed to be the space photo of the decade, but it looked like a mistake. At precisely 9:22 UTC on October 7, 2025, the European Space Agency released the first official image of 3I/Atlas, captured by the CASIS camera on the ExoMars Trace Gas Orbiter. The public expected the stunning high-resolution detail we've come to associate with our Martian probes. What they received was a single, fuzzy, underwhelming pixel against the blackness of space. The comet, with an apparent magnitude of +19, was incredibly faint. Within an hour, this blurry dot became a global phenomenon for all the wrong reasons. The team behind the camera, led by its principal investigator, Nicholas Thomas, from the University of Bern, knew they were pushing their instrument to its absolute limits. CASIS was designed to look down at Mars from an altitude of 400 kilometers, not out into the deep void. They had performed a complex slew maneuver, pointing the entire 4,332-kilogram spacecraft at a target 30 million kilometers away that was over 10,000 times fainter than anything the camera was built for. The resulting image wasn't a failure, but a triumph of engineering that required stacking multiple exposures to even get a detection. The world, however, didn't see a technical miracle. It saw a smudge and immediately began asking what was being hidden from view.
Global outrage.
That blurry dot didn't just disappoint, it sparked a wave of digital fury. The initial letdown quickly escalated into genuine outrage as armchair analysts and amateur astronomers launched their own inquiries. Social media platforms were flooded with side-by-side comparisons, pitting the fuzzy official image against captures from backyard telescopes that appeared to show significantly more detail. The comment sections on agency posts turned into forums for accusations, with many users convinced that ESA was hiding something profound. This anger was magnified by the coordinated silence from other spacefaring nations. NASA, China's National Space Administration, and the UAE Space Agency, all operating orbiters around Mars, released nothing. No images, no press releases, no confirmations of their own observations. This collective silence felt deeply suspicious. People began to question why 3 independent, highly advanced space programs would all fail to get a clear shot. As astrophysicist Dr. Jesse Christensen of the NASA Exoplanet Science Institute often explains, maintaining public trust is paramount in science, and transparency is key. Every unanswered question only intensified the pressure, transforming a scientific observation into a full-blown public relations crisis.
Technical limits.
So, was this a cover-up, or just the hard reality of physics? The truth is, the blurry dot was inevitable, and the numbers prove it. Let me explain. The CASIS camera, developed by a Swiss-led consortium including scientist Gabriele Cremonese, is an imaging powerhouse when pointed at Mars. From its 400-kilometer orbit, it achieves a stunning resolution of 4.5 meters per pixel. But 3I/Atlas was 30 million kilometers away. At that vast distance, the camera's angular resolution of 11.36 microradians per pixel translates to a pixel scale of about 340 kilometers wide. The comet's nucleus, the solid object at its core, was estimated by astronomers to be only about 15 kilometers across at most. This means the entire comet was just 4.4% of the width of a single pixel on the detector. It's like trying to photograph a single human being standing in San Francisco using a cell phone camera in New York City. No matter how perfect your focus, the light from that object will never fill more than 1 pixel. The fuzzy dot wasn't a blurry image of the comet, it was the entire image of the comet. Its faint light smeared across one single sensor element. It was a technical ceiling, not a conspiracy. The camera could only give a fingerprint, not a portrait.
High-rise goes dark.
Just as the world needed its most powerful eye on Mars, the camera went dark. NASA's Mars Reconnaissance Orbiter is equipped with the High-Resolution Imaging Science Experiment, better known as HiRISE. This is a formidable telescopic camera, capable of spotting rovers, and even their tire tracks on the Martian surface from orbit. It represented the best chance for humanity to get a clear, detailed image of 3I/Atlas's core. But as the comet made its closest pass by Mars, HiRISE was effectively out of commission. The reason was a US government shutdown that began on October 1, 2025, which froze the majority of NASA's day-to-day operations. All non-essential activities, including the uplinking of new commands to spacecraft and the public release of data, came to a halt. Astronomers, including the HiRISE camera's principal investigator Dr. Alfred McEwen, could only watch the empty public archives, waiting for data that would never appear. The shutdown severed the command chain, freezing the entire data pipeline. HiRISE's forced inaction created a crucial information vacuum, leaving the narrative to be shaped by blurry images and a growing cloud of suspicion.
Radio silence.
NASA's silence was deafening, but they weren't the only ones who went quiet. Two other powerful orbiters were perfectly positioned to observe 3I Atlas, China's Tianwen-1 and the United Arab Emirates' Hope mission. Both had been tracking the comet on its approach. Tianwen-1 carries a high-resolution camera capable of imaging Mars at a resolution of 0.5 meters. The Hope orbiter, managed by project director Omran Sharaf, has the Emirates Exploration Imager, or XI, a multi-band camera that could have provided crucial color data on the comet's coma. Yet in the days following the ESA image release, neither the CNSA nor the UAESA published a single frame of data. No press releases, no technical updates, not even a statement confirming they had attempted an observation. This coordinated silence from three independent space powers was, for many, the most damning piece of evidence. Experts in international space policy, like Professor Svetla Ben-Itzhak, have noted that while agencies often keep data proprietary, such a complete information blackout on a major public interest event is highly unusual. Why would three nations, often competitors in space, all simultaneously withhold their data? The lack of information felt less like a coincidence and more like an unspoken agreement.
The image wars.
While the professional agencies remained silent, the amateur astronomy community took center stage, and the internet became a battleground of images. In the days after ESA's underwhelming release, a torrent of pictures from backyard astronomers around the world began to circulate online. Using advanced techniques like stacking dozens of long exposure frames and applying AI-powered upscaling filters, these dedicated hobbyists produced images that seemed to reveal stunning details. One group, championed by popular online comet hunters, claimed to see a sharp nucleus and even faint jets of gas, arguing that their ground-based setups had outperformed billion-dollar orbital missions. However, professional astronomers, including Dr. Quanji Ye from the University of Maryland, urged extreme caution. They countered by showing how aggressive digital processing can create convincing illusions. They explained that astronomical techniques like deconvolution, when pushed too far, can easily amplify background noise, turning random digital artifacts into what look like real structures. The debate quickly became highly technical, but the fundamental issue, as the professionals pointed out, was the inescapable limit of optical resolution.
Perseverance streak.
So, while the world was really focused on the orbiters, the most intriguing clue, well, it might have actually come from the Martian surface. Over at the Jet Propulsion Laboratory, Justin Mackey, who is the imaging scientist for the Perseverance rover, authorized a pretty unique observation. The rover's navigation camera, or NavCam, was pointed toward the constellation Ophiuchus for about 10 minutes, taking a sequence of exposures as 3I Atlas was predicted to pass overhead. Now the raw frames, they revealed a single, faint streak, just over a pixel wide, cutting diagonally across the image. The math, it was tantalizing. At its known speed of 90 kilometers per second, the comet would have traveled exactly 54,000 kilometers during that 10-minute window, a distance that perfectly matched the streak's angular length if it was the result of motion blur. It seemed like confirmation, right? But then, rover operations lead Vandy Verma later noted a catch. The same streak could be produced by a much closer object, maybe a 10-centimeter piece of orbital debris from a past mission like Mars Global Surveyor, moving at just 7 kilometers per second over a shorter exposure. Without the full FITS data headers to confirm the exact exposure timing, the streak remained a 54,000-kilometer question mark, the first piece of hard but ambiguous data in a sea of speculation.
Wow signal link.
Just when the story seemed like it couldn't get any more bizarre, it intersected with one of the greatest mysteries in the history of astronomy. As scientists plotted the precise trajectory of 3I Atlas, they uncovered a jaw-dropping coincidence. A line drawn from Perseverance rover's location in Jezero crater through the comet on October 7th pointed almost directly to a region of the sky in the constellation Sagittarius. This patch of sky is famous for being the origin point of the WOW signal. Back in 1977, astronomer Jerry Ehman detected an incredibly powerful 72-second radio burst from this exact direction, a signal that has never been explained or heard again. The comet's alignment with this historic anomaly was just too perfect for the internet to ignore. Yet, despite the incredible coincidence, no major radio observatory, including the SETI Institute's Allen Telescope Array, under the guidance of senior astronomer Dr. Seth Shostak, announced a dedicated listening campaign on the 1420 MHz frequency of the original signal. The optical silence was now compounded by a profound radio silence, raising an unsettling question. With the geometry perfectly aligned, why did no one seem to be listening?
Approaching perihelion.
The mystery is reaching its peak, yet the main character is about to leave the stage. On October 29th, the enigmatic object known as 3I Atlas will reach perihelion, its closest approach to the Sun. It will plunge to a blistering distance of just 0.3 astronomical units, well inside the orbit of Mercury. For the following 38.5 hours, it will be lost in the intense solar glare, a period astronomers refer to as a blackout. This impending information vacuum is allowing every theory, from the mundane to the extraordinary, to flourish. Some astronomers predict the object might completely disintegrate under the intense solar radiation which will heat its surface to over 400 degrees Celsius. But others, including those from Avi Loeb's Galileo project, wonder if this blackout could be used to hide something else, a deliberate maneuver. The Galileo project has put forth a compelling theory: an engineered course correction of even a few dozen meters per second, masked by the sun's gravity, would be definitive proof of an artificial origin. In anticipation of this, the project has announced a plan to use the Allen Telescope Array to listen for any telemetry pings the moment 3I Atlas is expected to re-emerge from behind the sun's limb. The world will have to wait. The approaching blackout is the ultimate cliffhanger in a story already short on answers.
The November tests.
As 3I Atlas rounds the sun and is expected to re-emerge into view in early November 2025, a global campaign of intense scientific scrutiny is set to kick off. Astronomers will then focus on a critical checklist of tests to determine what might have happened during its solar passage. First, they will meticulously analyze its light curve, the graph of its brightness over time, searching for any sudden surges or steep drop-offs that would signal it has broken apart. Second, they will use the new data to run hyper-precise orbital models, looking for any tiny, unexplained deviations from its predicted path. Such a change could be evidence of natural outgassing jets, or as some are still theorizing, something far stranger. Hopes for an even better look are resting with ESA's Jupiter Icy Moons Explorer spacecraft, known as JUICE. Though it is on its long journey to Jupiter, it has a unique vantage point and a scheduled observation window. However, as confirmed by JUICE project scientist Dr. Olivier Wittas, the vast distance means that any data it collects won't reach Earth until deep into 2026. Until then, every new measurement from Earth will be another clue in a puzzle that has captivated the world. So, what is 3I Atlas? Is it a natural interstellar comet that arrived at the worst possible time, a victim of technical limits and bad timing? Or is the blurry dot, the synchronized silence, and the impossible coincidence of the WOW signal pointing to something more profound? The official story tells us of limitations, but the missing data tells a story of its own. We were given a front-row seat to one of the most significant astronomical events in human history, only to have the curtain drawn at the critical moment. The truth remains out there, hidden in the noise of a blurry image and the silence of the world's greatest observatories. Don't forget to like, subscribe, and hit the bell icon for more deep dives into the mysteries of our universe. Until next time, keep looking up Simply Science. What if a message from the stars wasn't a radio wave, but a silent flash of light speaking the oldest language in the universe? On October 13th, 2025, an interstellar object, thought to be long gone, sent a signal that defied all known physics. It wasn't random noise. It was a mathematical pattern, the same one that shapes galaxies and life itself, detected by two observatories on opposite sides of the Earth at the exact same moment. Let's explore this together.
The night of pulses.
What happens when the sky blinks in perfect rhythm? On October 13, 2025, at exactly 2:41 UTC, that question became terrifyingly real. The Cerro Tololo Inter-American Observatory in Chile and the Mount Abu Infrared Observatory in India, separated by nearly 8,000 miles, recorded the same impossible event. Three faint rhythmic bursts of light emerged from the darkness behind the sun. The source was pinpointed to the trajectory of 3I Atlas, an interstellar object that had disappeared from view weeks earlier. These weren't random flickers. They were structured, appearing in both optical and near-infrared bands, suggesting a controlled emission rather than a natural reflection. As Dr. Seth Shostak, a senior astronomer at the SETI Institute, has often said, a signal that is deliberately structured and information-rich is hard to explain away as a natural phenomenon. On their own, the pulses could have been dismissed as instrument noise or cosmic ray hits, common artifacts in astronomical data, but appearing identically at the same moment in two independent observatories, removed all possibility of coincidence. The synchronized detection transformed a potential error into a verified observation, forcing a re-evaluation of what was possible. The sky went silent, then it blinked, and the world was never the same.
Fibonacci sequence.
Is there a language any intelligence in the universe would understand? The answer is mathematics, and the pulses from 3I Atlas used one of its most elegant dialects. The intervals between the bursts were precisely 5, 8, and 13 seconds. This isn't a random set of numbers, it's a core section of the Fibonacci sequence. 0, 1, 1, 2, 3, 5, 8, 13, the famous pattern where each number is the sum of the two preceding it. First introduced to the Western world by the Italian mathematician Leonardo of Pisa in his 1202 book Liber Abaci, this sequence is nature's architectural blueprint. It appears in the spiral arms of the M51 Whirlpool galaxy and governs the principle of phyllotaxis, the arrangement of leaves on a plant stem, which often follows Fibonacci ratios to maximize sun exposure. The 19th century mathematician Edward Lucas, who gave the sequence its modern name, studied its properties extensively. The use of this sequence suggests a message designed to be universally recognizable as non-random and biological or structural in nature. For an interstellar object to emit signals matching this pattern was profoundly strange. It was as if it was broadcasting a page from the universe's own design manual.
Double confirmation.
How do you turn an anomaly into a fact? You get a second, independent witness. That's what made the 3I Atlas event impossible to dismiss. One observatory seeing strange flashes is a curiosity. It could be a bird, a satellite glint, or an equipment malfunction. But two observatories, on opposite sides of the planet, with different instruments and different atmospheric conditions, recording the exact same pattern signal within 0.04 seconds of each other. That is data. At Cerro Tololo, the sensors logged the bursts at precise Fibonacci intervals. At Mount Abu, the thermal imaging array recorded identical spikes, confirming the event occurred across multiple wavelengths. The odds of this happening by chance, from cosmic background radiation or simultaneous instrument failure, were calculated to be 1 in a billion. As the great astronomer Carl Sagan taught us, extraordinary claims require extraordinary evidence, and this dual detection was precisely that. The team systematically ruled out every known terrestrial and orbital source, leaving them with a deeply unsettling conclusion. The double confirmation was that evidence, forcing a stark choice upon the scientific community. Either they had witnessed an instrumental coincidence of astronomical improbability, or something out there was deliberately transmitting a mathematical sequence using pulses of light.
The golden ratio.
What if the message was not just in the timing, but in the light itself? The Fibonacci sequence is directly linked to another fundamental constant, the golden ratio, an irrational number that's approximately equal to 1.618, also known as phi. Back in the 17th century, the astronomer Johannes Kepler marveled at these divine proportions, believing they revealed the universe's geometric harmony. Now, analysis of the 3I/Atlas pulses showed its light wasn't just blinking. Its peak brightness actually scaled with each pulse. The intensity of the second pulse was roughly 1.6 times that of the first, and the third scaled similarly, matching the progression of phi. The physicist, Roger Penrose, has shown this ratio appears in fundamental physics and the geometry of space-time. To produce such a signal would require a mechanism capable of precise energy modulation, which is, honestly, far beyond random reflections off an asteroid. The energy distribution of the pulses also matched a logarithmic spiral, a form found everywhere from nautilus shells to the arms of hurricanes. This precise scaling across distance, frequency, and intensity simply could not be a random reflection. It had to be intentionally modulated.
The Fatima anniversary.
Why did the signal from 3I Atlas arrive on October 13th? For many, this date was not a coincidence. It was a deliberate echo through history. The event occurred on the 108th anniversary of the Miracle of the Sun at Fatima, Portugal. On October 13, 1917, tens of thousands of witnesses claimed to see the sun dance, spin, and emit brilliant colors before appearing to plummet toward the Earth. Sociologists like Robert Bartholomew have studied the event as a case of mass suggestion and optical phenomena caused by atmospheric conditions, but its cultural and religious power remains immense. It became a cornerstone of faith for millions, a day where the heavens supposedly intervened in human affairs. Now, over a century later, another impossible light show connected to a celestial body took place on the very same day. One was perceived as a divine miracle, the other was recorded as a mathematical signal. The parallel was impossible to ignore, suggesting a potential awareness of our history and myths. A celestial body performing impossible light movements, on the same date, separated by 108 years, felt less like chance, and more like a deliberate symbolic act of communication.
NASA's blackout.
When the most powerful eyes on the sky suddenly go dark, you have to ask why. Just hours before the 3I/Atlas pulses were detected, NASA's Solar Dynamics Observatory, or SDO, went offline for scheduled maintenance. The SDO is a workhorse, capturing an image of the sun every 12 seconds, across 10 different wavelengths, and generating nearly 1.5 terabytes of data daily. For it to go dark during such a critical window is, honestly, highly suspicious. Compounding this, the high-rise camera on the Mars Reconnaissance Orbiter, which can resolve objects down to 30 centimeters on Mars, had been inactive since October 1st. Nicola Fox, the head of NASA's Heliophysics division, oversees these missions. The official explanation cited routine calibration overlaps, but for two premier systems to be down simultaneously felt, to many, too convenient. The SDO's atmospheric imaging assembly, in particular, would have been the perfect instrument to confirm or debunk the pulses directly. Its absence created an unfillable data gap, fueling speculation that this was not maintenance, but a deliberate blackout.
Harmonic resonance.
Was the 3I Atlas signal just numbers, or was it a form of music? According to the work of theorist David Sarita, the signal was a frequency map that aligned perfectly with his hyperdimensional solar model. In this framework, the numbers 5, 8, and 13 are not arbitrary. They correspond to specific harmonic resonances within our solar system. The number 5 relates to Earth's orbital position, 8 to a stable interplanetary zone beyond Mars, and 13 to a deep gravitational shell near Jupiter. Sarita's interpretation reframed the event entirely. The object wasn't just blinking a code, it was striking a cosmic tuning fork, creating brief flashes that carried harmonic energy across the vast distances of our solar system. This idea echoes the ancient concept of musica universalis, or music of the spheres, a theory the great astronomer Johannes Kepler dedicated his life to proving in the 17th century. Kepler believed the planets moved in orbits that corresponded to musical notes, creating a celestial symphony. While his specific theory was incorrect, Sarita's analysis proposed a modern version, that the 3I Atlas pulses were a physical manifestation of the deep mathematical and resonant structure of our own solar system, a structure we are only just beginning to understand.
The Dante connection.
Could a 700-year-old poem hold a clue to an interstellar message? In the 14th century, the Italian poet Dante Alighieri wrote Paradiso. In it, he describes heaven as 9 concentric celestial spheres, with their structure governed by precise numerical and geometric principles. The year of Dante's death, 1321, is exactly 704 years before the 2025 event. Physicist and Dante scholar Mark A. Peterson published a famous paper in 1979, arguing that Dante's cosmos wasn't just concentric circles, but a hypersphere, the three-dimensional surface of a four-dimensional ball. The rhythm of ascent in Paradiso mirrors patterns of growth similar to the Fibonacci sequence. Now, this isn't to say Dante predicted the signal, but that the mathematical patterns of order and growth are so universal they appear in both our deepest artistic intuitions and in signals from the cosmos. The idea that an interstellar signal in 2025 would use the same sequence is, honestly, staggering. It raises the haunting possibility that this mathematical pattern is a universal signature of intelligent design, an archetype recognized across cultures, centuries, and perhaps even worlds.
Observatories respond.
How does the scientific establishment react when faced with the impossible? With extreme caution. For nearly a week after the event, the Cerro Tololo and Mount Abu observatories remained completely silent, consulting with international astronomical bodies. When they finally issued statements, the language was sterile and non-committal. They confirmed the data was real, the timestamps were synchronized, and the pulses were detected. But they refused to speculate on the source, labeling it a non-repeating, transient, photometric anomaly. It was a phrase designed to say everything and nothing, acknowledging the event while stopping short of any extraordinary interpretation. Yet, the data they released spoke for itself. The photometric light curves showed three sharp, distinct peaks with perfect Fibonacci spacing. As planetary astronomer Dr. Frank Marcus of the SETI Institute would argue, you must first exhaust all possible natural explanations, no matter how unlikely. But here, every known natural cause, cosmic rays, satellites, instrumental errors, had been systematically ruled out by their internal reviews. The observatories published their findings not with a press conference, but in quiet technical bulletins buried in their archives. But the message was clear. The signal was real, it was verified, and it was now part of the scientific record.
The missing data.
Sometimes, the most important clue is the evidence that isn't there. As researchers and the public scrambled for answers, all eyes turned to NASA, whose silence was deafening. The data from the Solar Dynamics Observatory for the entire period of the 3I Atlas event was missing from the public archives. This was a gap where 1.5 terabytes of crucial solar data should have been. There was no error note, just a void. Edward Tufte, a pioneer in data integrity, teaches that such omissions are often more revealing than the data itself. This silence wasn't limited to NASA. The European Space Agency's solar orbiter issued no comment, despite being in a perfect position to observe. The Japan Aerospace Exploration Agency JAXA also remained quiet. NASA has strict protocols for documenting data gaps from missions like the SDO. The complete absence of such documentation was a major breach of their own standards of transparency. This global information blackout became the smoking gun, transforming the narrative from a scientific puzzle into a potential cover-up. In the end, we are left with a hauntingly simple pattern: 3 pulses of light, with intervals of 5, 8, and 13 seconds. It was a signal that used the universal language of mathematics, broadcasted on a date loaded with historical symbolism, and confirmed by 2 independent witnesses. Yet, the agencies with the power to verify it were conveniently looking the other way. Was 3I Atlas a natural phenomenon so bizarre it mimicked intelligence, or was it a deliberate message from something far beyond our understanding? A cosmic hello from a passing traveler? We may never know for sure, but its journey through our solar system served as a powerful reminder that the universe is far stranger and more mysterious than we ever thought possible. It proved that we are not just looking at the stars, something may be looking back. What do you think 3I Atlas was? Let us know in the comments below. Don't forget to like, subscribe, and hit the bell icon for more deep dives into the universe's greatest mysteries. Thank you for watching Simply Science.